Hi, this is Pre-Algebra Lesson 9-1, Understanding Likelihood and Probability. So in this lesson, we'll be able to describe the likelihood that an event will occur. Let's start with this solve and discuss it problem. For a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has a big prize. 3 boxes have a medium prize. And 3 boxes have smaller prizes. 1 box is empty. How confident should he be that whatever box he chooses, he will win a prize? Support your response with a mathematical argument. Okay. So in a show, you have 8 boxes, and then he's going to choose 1 box. And you already know 1 box has a big prize, 3 boxes have medium prize, 3 boxes have smaller prizes, and then 1 box is empty. So your first guess, without even just like trying to explain yourself, because you just know 1 box is empty and you know the total boxes are 8, you just pick anything, and you would know that is a good probability that most of the boxes are going to have some kind of prizes, right? But how would you explain that? Let's think about some probabilities. That's why we need probabilities. So you can explain in different ways, but I'll show you one way, okay? So first of all, look at the big prize. Big prize is only 1 box, so 1 out of 8 would be the probability. And then of the big prize, right? For medium prize, it's 3 out of 8, right? And the smaller prize is 3 out of 8 as well. And then one box that is empty would be 1 out of 8. So the probability of picking the box that is empty and picking the big prize would be the same. It has the same probability. But most of it would just be medium or smaller prizes, right? So let's say that we can add the number of possible prizes and compare it to the number of boxes. And how do we do that? We know that big prize is 1 out of 8, medium prize is 3 out of 8, small prize 3 out of 8, and then the empty box 1 out of 8. And the number of any prize box would just be 1 plus 3 plus 3 plus 1. 1 plus 3 plus 3, right? Any prize. That would be 7. So 7 out of 8 would be the possible prizes for any kind of prize. Okay? So you can say that he has a 7 out of 8 chance of winning a prize. And that also means he has a 1 out of 8 chance of not winning a prize, right? So should he be confident or not? Yeah, it's a good probability, so he could be confident that he will win a prize. Now, does that mean he will win a prize no matter what? No, there's still a chance that he will choose an empty box, but he should still, most of the time, it's a good probability that he will win a prize. But if he picks that empty box, that 1 empty box out of the 8, then that's his choice. It's just, it's just low probability, but it still happens, right? So we could recommend that he could be confident, okay? Because he has a good probability, good chance. So this is what we're going to talk about. Probability. Oh, let's look at, let's not forget the last part. Suppose an empty box is taken out of the game. How confident should Jared be that he will win a prize? So now we don't even have the empty box. This is a very easy question, right? A straightforward question. If there's no empty box and every box has a prize, then he can feel certain. So instead of just feeling confident, he could be certain that he'll win a prize because the only box without a prize has been removed. So every remaining box has a prize. Let's write that down. There we go. He should feel certain that he will win a prize. Okay? Alright, are you done writing? Can we move on? Let's move on to the next page. So, the essential question for this lesson is, what is probability? So what is it, right? It's talking about what? It's talking about chance. How likely are you going to get it? Alright, let's look at example 1. Use probability to describe chance. Elisa and Cherry spin the pointer to the right and record the color that it lands on. The table shows their results after 100 spins. How can Elisa and Cherry explain their results? So they spun it 100 times. And this is the frequency of each color. So frequency basically talks about the number of happening. Okay, so they spun it 100 times and they got 23 red, 24 yellows, 27 greens, and 26 blues. You see that? And if you look at the graph, they're divided, are they divided evenly or unevenly? If they're divided unevenly, you might probably see something like this, okay? Then, of course, these two pieces look a lot smaller than these two pieces, right? So then that would be uneven. But if you look at the graph here, the spinning table here, they are divided equally in fourth. So there are 4 possible results. By theory, they should have an equal chance of everything, right? But if you look at the actual results, they all have different numbers, and that's pretty common in real life. You have a probability that's in theory, but it just never happens perfectly like that, right? Our world is like that. That's why it's unexpectable, but we do see that it has a pattern. The numbers are actually pretty close to each other, right? It's not perfectly the same, but they're close to the probability. So probability does have an effect, okay? That's why we're learning it. There are 4 possible results, or it's called outcomes. In real life, whatever actually happens, that would be your outcome, okay? It's different from the probability, but outcomes is also very important for you to think about future probability. So let's move on. When Elisa and Cherry spin the pointer lands on the red section, yellow section, green section, blue section. Those are outcomes, right? So how many outcomes do you have in total? How many different outcomes do you have? 4 different outcomes because you have 4 different colors. So each of the 4 outcomes is equally likely because each section is the same size, right? There's 1 section of each color. The pointer has an equal chance of landing on any of the 4 sections, okay? And each time they spin the pointer, the likelihood or probability of the pointer landing on red, yellow, green, or blue is the same. So probability in another word is the likelihood. How likely is it gonna happen, right? Each of the equal size sections is shaded 1 of 4 colors, so the probability of the pointer landing on any given color is 1 out of 4. Or you can write that as a ratio 1/4. Okay? Since 1/4 is 25%, you can also write that as a percentage. Each color has a probability of 25% of getting it. Okay? So the pointer should land on each color about 1 out of 4 times, or about 25 times out of 100 spins. So if you look back at the outcomes, 25 should be the number that they should all be close to. Okay? And it looks like that's an accurate probability, right? Yeah. Let's look at the try it question. How might the probability of the pointer landing on a given color change for the spinner shown at the right? Now we have a different spinner. Can you figure out the probability of these colors again. Okay? And can you explain why? So if you have time, you can also self-convince me. Okay? But pause the video and come back after you've thought about it enough and have an answer. Okay, are you ready? So, you've had time. Have you counted the colors, right? So let's look at the red color. Red, you have 2 red colors out of how many total? 1, 2, 3, 4, 5, 6, 7, 8 total. So red is 2 out of 8. And that's 1 out of 4, right? And then look at yellow. That's 2 out of 8 as well. And they're all equally divided. The sections look equally the same, right? And that's 1 out of 4 too. Green, 2 out of 8, 1 out of 4. Blue, 2 out of 8, 1 out of 4. So how does it change? Does it change? No, it doesn't. And it's okay if it doesn't. Okay, you're gonna say the probability will not change. And you can explain, even though there are now 2 sections for each of them, we've basically divided the original sections in half. And so there's still an equal number of sections shaded, and the sections are all the same size. So the probability of the point of landing on any given color is 2 out of 8, which is equivalent to 1 out of 4 as well. And they have the same percentage as well, 25%. Okay, these are all 25% each. So let's write that down. Okay, there we go. So probability will not change. All right, let's look at convince me. How would the probability of the point of landing on a given color change if the spinner had 6 equal size sections with each section a different color? So they have 6 equal sections. The probability of the pointer landing on a given color would be what? But did they say 4 colors? They didn't. So if they just have 3 colors, then they would just have the same probability. But if it has to be the same color, then you might have a color that will be repeated, but and some colors that wouldn't have 2 sections, right? Yeah, so think about it by drawing it. So if you have a pointer, and then we're going to divide this in 6. That means I'm going to divide this by 3 parts first. And I'm going to divide each 3 parts equally by half so that I have 6. Right? And then, so disregard my non-straight lines and imagine these are all equal parts. So if we say, oh, that's red, and each of them are going to be different, right? So because each of them are going to be different, they can't just be 4 numbers. They have to be all different. Sorry, not numbers. Color, right? They all have to be different color. So now we don't just have red, yellow, green, and blue. We should have different colors. So we can add what? We can add purple here. And then what else? I'm tempted to do pastel purple. But let's do brown. I just really like purple. No, actually I really like all colors. Okay, so these are all different colors, right? So how would the probability of the pointer landing on a given color change? If they're all different colors, then, and they're all equally divided by 6, then they should still be the same, right? That's 1 out of 6, 1 out of 6, 1 out of 6, 1 out of 6, and so on. And so they're all the same probability, or about 17%, or 16.66666 repeated percent. Okay, let's write that down as well. Okay, there we go. The probability of the pointer landing on a given color would be 1 out of 6, or 1 over 6, or about 17%. Okay, that was example 1, and try it and convince me. Let's look at example 2. Use probability and likelihood to describe situations. Carrie will roll a number cube with sides labeled 1 through 6. So cube has 6 different sides, and it's going to be a die will be labeled 1 through 6. So part A, what is the probability that she will roll a 2? How many 2s do you have in a die? 1, right? So only 1 out of 6 total size is a 2. So probability is 1 out of 6, or 1 over 6, or we talked about it in the last question, about 17. Okay? 17%. Don't forget the percent if you're going to go with the percentage. What is the probability that she will roll a number less than 7? And now, this is not just 7. Any number less than 7. Are we including 7? No. If it says at most 7, then we can count 7, right? But if it's less than 7, 7 is not less than 7. So we're not going to count 7. So any numbers less than 7 is 1, 2, 3, 4, 5, and 6, right? Everything is less than 7 on a die, right? There is no such number as 7 in this die. Some die may have it, right? But all 6 numbers on the cube are less than 7. So that just means we're certain that we're gonna get a number less than 7. However we roll, there is no way that we're gonna get a number greater than 7 or equal to 7, right? So the probability of 6 out of 6, or 1, or that's 100%. What's the probability that she will roll a number greater than 6? Now, so think about numbers greater than 6. Do we include 6? No, 6 is not greater than 6, so we're not including 6, okay? So 7, 8, 9, ... Do we have these numbers on a die? No, not on this die. So, not on this dice, right? So 7, 8, 9 wouldn't even have a chance, right? So none of the 6 numbers on the cube is greater than 6. So it is impossible to roll a number greater than 6. So probability is 0 out of 6, and 0 out of 6 is just 0. And that's 0%. Okay, good. So these are some situations that you will see, and you want to figure out the likelihood of them. So basically, you need to figure out the ratio, and then you can figure out the percentage. But right now, you can just look at the ratios, okay? If you can write the percentage, please write percentage too, just to practice. It's going to come later. So let's try it, pause the video, and look at this question of having game piece having 12 sides labeled 1 through 12, and figure out the probability of these different situations. Pause the video and come back when you're ready for answers. Okay, are you ready? So what's the probability of rolling an 11? Do we have 11 between 1 and 12? Yes. How many 11s do we have? Just 1. So 1 out of, how many total do we have? Not 6, 12 pieces total, right? 12 sides total. So 1 out of 12, or you can have 1 over 12. Okay? What's the probability of rolling a number greater than 5? Greater than 5, you have 6, 7, 8, 9, 10, and 11. And 12, right? So everything from 6 to 12 would be possible. So 1, 2, 3, 4, 5, 6, 7 sides out of 12, right? So 7 out of 12 would be 7 over 12. Okay? And what's the probability of rolling a number greater than 12? Greater than 12 would be 13, 14, 15, and so on. We do not have those numbers on this game piece. So it's 0 out of 12, which is impossible. There we go. Check your answers. And we'll move on to example 3. Use probability to examine fairness. Marisol designed a spinner for a game. The spinner is fair if there is an equal chance for the pointer to land on each letter. Is the spinner a fair spinner or not? Okay, let's look at this description. The spinner has 6 equal-sized sections. 2 sections are labeled A. And then the other sections we see E, D, C, and B. You already have an idea that it's not fair because you have 2 sections that are A, and then all the other sections just have 1 section per letter, right? So the probability of the pointer landing on A is 2 out of 6, which is 1/3. Okay? But probability of pointer landing on B is 1 out of 6. So A would be 2 out of 6, or 1/3. B is 1 out of 6, C is 1 out of 6, D is 1 out of 6, E is 1 out of 6. So is this fair? Do they have all the same ratio or probability? No, right? It is more likely that the pointer will land on A because you have 2 sections for A that are equally divided than any other number. So it's not a fair spinner. Okay? Let's look at try it. Is the spinner shown a fair spinner? So think about what fair means. It means that all different options or outcomes should have equal chance. Okay? If they don't, it's not a fair spinner. So think about this and try to explain your answer. Come back when you're ready to check the answer. Okay, are you ready? So is this fair or not? How many options do we have? You may think we have 2 options because we have red and blue. No, we have no color as an option too, right? So that is an outcome. Your spinner can spin on this land, it can land on this part, right? So yeah, we have 3 different outcomes that are possible. Is this fair? You can already see that the blank, the white part, is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections, right? So that's 1 out of 10. And the red would be 1, 2, 3, 4 out of 10. And blue would be 1, 2, 3, 4, 5 out of 10. So they all have different ratios. If you want to double check, you can simplify their ratios and see if they're equivalent fractions. And they're not, right? So obviously this is no. Explain, the sections are all the same size, so they're all equally divided, but 5 sections are blue, 4 sections are red, and 1 section is gray. So the spinner will be fair if the gray section is shaded red, because the probability of the spinner landing on either blue or red would be, then will be half and half, right? If this gray section were to be colored red, then it would be a fair spinner. But it's not. So unfortunately, it's no. So let's write that down. So here you go. No, the sections are all the same size, but 5 sections are blue, 4 sections are red, 1 section is gray. The spinner will be fair if the gray section is shaded red, because the probability of the spinner landing on either blue or red will then be 5 over 2, 5 over 10, or 1/2. There we go. Alright, that was lesson 1. Let's summarize our lesson. So the probability that something will occur is a value from 0 to 1, where it describes its likelihood. Yeah, you can write the probability as ratio, such as 1 out of 2 or 1 over 2, or as a percent, such as 50%. Okay? So this is an example that summarizes our lesson. The probability of rolling a 7 is 0 out of 6, right, from this dice. So that's impossible. So there's not a chance, 0%. The probability of rolling a number less than 7, which is all the numbers, right, is certain. Is 6 out of 6 or 1 or 100%. Okay, the closer the value is to 1, the more likely it is that the event will occur. And if you look at the coins, that's also a good example, common example of real world situation about probability. The probability of landing on heads to tail is 1 out of 2 or 1/2. That's a 50-50% chance. So for a 50-50% chance, flipping a coin is a really good example for a 50-50% chance. If it's less than 50, it's unlikely. If it's more than 50, it's likely. And the closer it is to 1, it is very likely. Or if it's exactly 100%, then it's certain, right? The closer it is to 0 is very unlikely. And as soon as it hits 0%, it's impossible. All right, that was lesson 9-1, understanding likelihood and probability. So that should have been a good introduction of the entire topic and the general idea of the vocabulary we're going to use. All right, guys, if you have any more questions, please ask Ms. King in class. Otherwise, I'll see you in the next lesson, in the next video, in the next lesson. Bye!